Hello all, welcome to the video lecture. In this video, we'll be discussing about hypothesis testing. We use hypothesis to interpret or draw the conclusions about the population using sample data. And a hypothesis test evaluates two mutually exclusive statements or claim about the population to determine which statement is best supported by the sample data. And before we start with, let us look at some terminologies that we should be aware of in hypothesis testing. And let's begin with the sample and population. Well, population is the complete collection of all elements that we are going to study, and sample is just sub collection of elements from the population. Like while we considering the population, it can be like cities, students, or factories, or so on, and it depends on the study of our interest. And the sample is it's just the sub collection of elements that we have considered in the population. And another term is the parameter and statistic. Like a parameter is a value that describes the characteristics of the entire population. Like the population mean, standard deviation, and proportion are common parameters, and sample statistic is the summary of or the summary description of characteristics or measure of the sample. And it's usually used to estimate the it is used as an estimate of the population parameter. And for example, sample mean, sample variance, sample standard deviation, sample proportion, and these are the sample statistic that we use. And other thing that we have to consider about is the z value. Well, we discussed in our last class in the probability distribution functions, where we had discussed about the standard normal distribution and standard normal distribution. There we had studied about the variance and the standard deviation, variance, and the mean. And here we also consider that distribution, like the standard normal distribution or standard or normal distribution. And here z value is the measure of standard deviation, that is how many standard deviation away from the mean, and it is like the z value is the measure of the standard deviation, that is how many standard deviation away from mean is the observed value. For example, suppose if we have plus 1.8, if the z value is equal to plus 1.8, it can be interpreted as it is observed value, which is 1 plus 1.8 standard deviation away from the mean. We can see here, like suppose if we have got this as the mean, because we are taking this the standard normal distribution where the mean is 0. And here what happens is, if the z value means it is 1.8 away from the it's 1.8 away 1.8 standard deviation away from the mean, means as it is in the positive, it consists of plus, so it goes plus 1.8 away, plus 1.8 standard deviation away from the mean. And in standard normal distribution, this standard deviation is 1, so we can say that it is plus 1.8 away from the mean. And this z can be estimated with this formula. Here x is the some observed value, and mu is the mean, and the sigma is the standard deviation. So these methods always work with the normal distribution, and as I discussed, these methods always work with the normal distribution as shown as shown above, and not with other distribution. In case the population distribution is not normal, we have to resort to the we have to depend on the central limit theorem. So before we start with the central limit theorem, suppose let's say an example, and then we will describe about the then I will describe about the central limit theorem. The like it is the one of the most important theorem in statistics, and let's consider the student. Suppose it's the students from Chosun University High School, and there are 1000 students, and if we plot the marks obtained in mathematics, suppose, and the frequency distribution and plot of the marks will be shown as in figure. Like this is the marks that is obtained, and this is the frequency distribution. This is the number of like it's the frequency, like the how many, like suppose for one there are, we can say that 3 students obtained 1 in math, and we can say that 2 maybe 17 students scored just obtained 3 in mathematics. So this is the plot of the frequency distribution of the students versus the marks. And now like what we see here is like it looks like randomly distributed to all the students. Like we can see that the distribution is random. And now if we select the sample, like if we select the sample of 40 students randomly from the population and calculate the mean of these students, and we can do this for suppose 1000 samples of 40 randomly selected students and calculate the average of that sample. And here we have got the 40 is the sample size, and each sample has its own mean value, and its value is different, and the pattern of sample means represent the sampling distribution for students obtained in the math student, like the math in student in the high school of Chosun University. And this distribution from this example represents the sampling distribution of the mean, because the mean of each sample was the measurement of interest. And if we look at the frequency distribution of this sample averages of 1000 samples, we get the distribution mean like we get the distribution of mean and other statistics as, like we can see this is the distribution, and we can see like here we have got the mean of mean about is 48.5, like we can get up to like this, in standard deviation to be 4.61. And from this what we can conclude is like the mean of the sample means, like it is the mean of sample means, like we have got the 1000 sample means is very close to the population mean. Suppose like if we compare the population mean, suppose we are given the population mean and we estimate the mean of the sample means, then suppose the number of sample means is around 1000, and what we get is the mean of sample means is very close to the population mean, and the standard deviation of sample distribution can be found out from the population standard deviation, which is divided by square root of sample size n, and it is also known as the standard error of the means. Now this standard error of means is nothing but the standard deviation population divided by the sample size n. And another important thing that we can notice here is the distribution of sample means is normal regardless of the distribution of the actual population. So it doesn't matter what distribution that we follow. If it's already standard, if it's already normal distribution, then uh, it will be normal. And if the distribution is random, like we, as in our example, the distribution of this sample mean will be normal. Well, the shape of the distribution of sample means tends to be normal, and it is guaranteed to be normal if either a population from the sample are obtained from the normal distribution, like the originally it's normally distributed, uh, and other is the if the we take the uh, sample size and to be greater than or more equal to 30 or more than 30, then the distribution of the sample mean will be normal. So it's all about the basics of the terminologies for the hypothesis testing. Next we'll be discussing about the hypothesis testing in more detail.